Hello. In this video, we are going to be looking at the results of an experiment we conducted on our 3 temperature sensors to test the effectiveness of the correction factor that we created in the last video. Now, in this experiment, we submerged our PCB, which was insulated, into an ice bath, and we let that sit for about 10 minutes to establish a baseline of 0 degrees or thereabouts. We then brought the ice bath up to about 32 degrees Celsius using a hot plate, and then allowed it to cool down to room temperature and stabilize to get a sort of secondary baseline. Now here we have the data that we collected. You can see that we have 5 columns. We have the first one, which is for the PT1000, and this is using the ESP's built-in ADC with our correction factor that we saw in the last video. And the next one uses an external ADC, which is a lot more precise and accurate and sort of works out the box without correction factor. So that'll be interesting to compare. We have the TSIC and the Dallas, and we have a raw temp, which is the ESP's ADC without any kind of correction factor. And you can already see that that is quite a significant bit off from all the other sensors. Now in this script, we have loaded our data that you saw there into a variable called data, and we can run this cell here to create a graph, and there it is. You can see our 4 data sets here, which are all pretty close together, and then the uncalibrated EDC is way off down here with a significant difference. And it's interesting to note that the ADC, which you'd expect to be quite accurate, is different to the ESP. The other thing you can see is that the ESP is quite noisy in comparison to the other sensors. And we even had a sort of 50 measurement rolling average. So that was supposed to reduce any noise we saw, but you can see it's still quite a noisy graph. And this could be because of the lower resolution of the ESP, so it's jumping between one measurement and the measurement above it. But it's just quite interesting to see sort of the size of that noise there. So here we have a graph, and this is looking at the first 400 data points from this graph here, and we've taken out the raw temperature to allow us to look at that closer. So here we have it here, and you can see the baseline for each of the sensors, and you can see that the ADS and the TSIC are just about in agreement, with the Dallas sitting around 0, and clearly the ESP, because it's lower resolution with its 12-bit ADC, is bouncing all over the place quite a bit. But when you zoom out and you reduce that noise using, say, a smoothing function, you can see it's sort of hovering around this mark here. Now we have data points 400 to 800, and this is the ramp up, so this is when we started heating the sensors. And you can see that the ADS reacts the quickest to these temperature changes. You can see the yellow and the green line here are agreeing, so that's the ADS and the TSIC. And then they grow more separated because the TSIC takes longer to heat up and is less sensitive to change than the ADS, because it's a thicker sensor, whereas the PT1000, because it's quite small, changes temperature quite quickly and is a bit more reactive and sensitive. And now we have the last 500. So this is when the water had cooled down to about room temperature. You can still see there's some cooling going on. But interestingly here, the ESP, the TSIC, and the Dallas are all in agreement here, whereas the ADS, the external ADC, is about a degree higher than the rest of them. And this graph really shows quite well the difference in resolution between all the different sensors and ADCs. So you can see here that the ESP's ADC, when it's going between 2 values that are next to each other, it's got quite a large gap. And then the next smallest is the TSIC. You can see a much smaller gap than the ESP. And then the Dallas here, an even smaller gap. And then when we go up to the ADS with its 15 bits of resolution, you can see the gaps are really quite small, and looking at that in relation to the scale of the y-axis, you can see that's, a hundredth of a degree really. Now if we look back at the data, you can see when the ESP is reading 0, and this was when we had our ice bath, the TSIC and the Dallas consistently read above 0, and that's because they've got a degree of self-heating. All the sensors have some self-heating, but it appears the TSIC has a lot more than the others. So thank you for watching this short video, and this was just to show you the effectiveness of the correction factor and how good it can really be at helping your temperature be something more feasible, unlike this. So thank you for watching.